Okay, to meet our next presenter, we need to cross the border into Belgium and welcome Cindy Verhoeven with the Sniffers. Cindy holds a degree in mechanical engineering. She worked for 17 years in the field of pipeline quality and safety in the logistics supply chain of pipeline construction. She continued her career in the flow metering industry, working for a manufacturer of flow computers and metering supervisory software solutions. She currently holds the position of regional manager at the Sniffers and is responsible for several global key accounts and geographical areas, including the Netherlands, Germany, Northern Europe, Spain, and Latin America. Cindy, thank you for joining us today to describe how to manage pipeline integrity with a pipeline risk and integrity management software solution.
Thank you, Danny, for the nice introduction. Yes, so today I'd like to have a presentation on pipeline risk and integrity management. Oops, a little bit too fast. Pipeline risk and integrity management solution for safe and compliant and efficient pipeline operations. And what I mean by that is the combination, the essential combination of field surveys, good data management, and also a software system to manage all that data that I would like to present. So a very short introduction of the Sniffers, not to take too much of the short time. So the Sniffers is an environmental service provider. We are active globally in 35 countries, and we are a service provider for the oil and gas industry in the widest sense of the word. So the full supply chain. We provide field services, consultancy, so advice, and also software platforms, and all in the area of emission quantification, leak detection, and pipeline integrity. So we have a wide range of services, and I feel that's also our experience that is quite key for good pipeline data management, is that you combine excellence in field services, but also on the data management and software side. So typically we see data is scattered all over the place. Some data is managed in a software, other data is still somewhere available on paper documents, and what we aim is to bring everything together in one platform. Our platform is called PRIMS, which means Pipeline Risk and Integrity Management Solution. So PRIMS is one platform for all pipeline data. So on the left side, you see the data that can be entered into the platform, which is pipeline documentation, drawings, right-of-way diagrams, etc. Inspection results coming from inline inspections or other types of field surveys, leak detection, cathodic protection, coating surveys, and also monitoring of third-party activities, which is still a major cause of pipeline damage, and risk assessment information. Then the output of the software is depending on several modules that can be active. And well, in the presentation, I will go through several of those modules, given the available time. So first of all, pipeline documentation. We aim to digitalize and also enhance the quality of available pipeline data and drawings. And the idea is to have the best accurate data available in the software and to build a 3D model in the best way possible. So with all the properties, the features, the XYZ data, the individual welds, etc. Also right-of-way documentation can be handled in the software. I'm going through this a little bit fast. Then, of course, the inspection information. which is very important for condition assessments of the pipelines. So the software can take in data from various sources, ILI inspections, cathodic protection surveys, different types of coating surveys such as SIPs, DCVGs or ACVG, leak information performed by various inspection methods. It can be leak detection by foot, by car, or even aerial inspections. And also, for example, internal and external metal loss, which is obtained by corrosion assessments. Excuse me, let me get a drink here, yes. So what we do with that data is we plot the internal and external corrosion data on a map overlay of the pipeline, together with all the features that are already available. And that's what you see here. And immediately the risk points become clear on the map. So here on the x-axis, you will see the length of the pipeline, and the red line is the clock position. So basically, if you would cut the pipe open and make it back into a flat metal sheet, then the red line is on the 180 degrees, which means it is the bottom of the pipeline. So here you see a combination, what we can do with all that data coming from various sources. So for example, external corrosion surveys, we can combine with metal loss surveys based on coating or SIP surveys that you see here. And basically on the same position of the pipeline, you can identify problems that can occur when you perform several surveys. And based on that analysis, you can derive certain conclusions that would otherwise remain invisible if you only have one data layer. So what we see is that the combination of data layers in that software is crucial for a good pipeline condition assessment. So this was an analysis for external corrosion. And here you see an analysis for internal corrosion, where we plot ILI data, again over the length of the pipeline, clock position on the y-axis, and below you see the pipeline profile, which is basically here, the gray line is the, the soil, and the blue line is the pipeline. So immediately you see that the problems occur on the lowest point of the pipeline, which is a river crossing. And based on this data, you can derive the ERF and P-safe factor for the pipeline. So the ERF is the estimated repair factor, and P-safe is the safe operation pressure for the pipeline. Here you see the same data plotted in a graph. So this is based on a single survey. The green line is the 80% metal loss line, and the yellow line is the ERF, the estimated repair factor, and all the data points need to be at least below this line to allow a safe operation. So on the left side, the graph that shows that the operation of the pipeline is safe. But there is one point that you see also here on the right graph that is coming pretty close to the maximum operation pressure. The green line here is the maximum safe operation pressure. And obviously here all the points are still above that line, but there are some risks to be expected in the near future. What is also important is that the software performs these analyses according to the standards, as you can see here below. So ESME, British standard, the API 579, and DVGW 473. If we move further, we can also compare several of those analyses to each other. For example, you have performed an ILI run here, for example, in 2010 and in 2015, and you're going to compare that data. And on the same spot here, on the length of 2,200 kilometers, you see here that we have a growth. When we compare those data sets, we have a corrosion growth of 3 millimeters. So that these are analyses that you can do based on if you build historical data in the software and compare several surveys. Of course, if you compare historical data, you can also predict something for the future. And I think that is also quite important to make choices and to make decisions on investment, repair costs, and also operating pressure. So here you see the same point. It is marked in green. And if we make a forecast for 10 years, for example, you see that this point will become above the ERF line together with some other data points, but this was the first one that will be our concern. So we need to take some action in the near future. And also on the right, you see that that point will be very close to the safe maximum operational pressure. Here you see the same data sets. So from 2 surveys plotted in the projection over time. And then indeed you see here, this was 2018. You will have to make one investment. This is a critical feature that you will need to repair in order to prevent problems in the near future. So these are assessments that the software can do, and it makes it very easy for pipeline operators and owners to make those decisions because it becomes very, very visible and very tangible. So based on those fitness for purpose and remaining life assessments, you can do a life cycle assessment for the pipeline. Again, this is fully aimed to make decisions and also to be able to predict decisions in the near future. So expected a level of repairs and also the costs that come along with those repairs, and also choices based on the desired service life of the pipeline. So then finally, the final module in the software is also risk assessment. So through all that data, we are going to look at the likelihood and consequence of pipeline incidents to happen. And so many factors can be a part of that risk assessment. So these parameters are, for example, damage of third party, the corrosion and the corrosion growth, design parameters, operational risks, etc. So a Kent-Mühlbauer model is used for this risk assessment. And yeah, it gives, we feel that by combining the expertise in the field surveys combined with the data sets that are available in the software, we can provide this type of in-depth advice to the end customers, the pipeline operators, and they can then base their decisions accordingly. So this was my my full presentation, and I welcome any questions.
Well, thank you very much, Cindy, and nice to meet you. Thanks for the presentation.
Nice to meet you too. Let me see if I can now make the other screen visible again. Yes.
So is this a system that can be applied to onshore and offshore pipelines?
Well, for onshore pipelines, there is more. We can have more types of surveys available that are very easy to integrate in the software. So yeah, it's always the case that, of course, the result is as good as the data you can put in. So depending on the survey data that is available, it can apply both for onshore and offshore, but definitely richer data sets for the onshore part. That's also mainly because our field expertise is in onshore pipelines.
Right. Yeah, makes sense. It's exciting to hear about building a 3D model of the pipeline. Is that the sort of thing that could be combined with augmented reality, you know, in a eye visual software?
In the future, I'm sure. Yes, it's well, the software is of course very much susceptible to developments. Right now, this is not the case, but yeah, with software you cannot stand still. And obviously, as we heard in the presentations before, augmented reality and yeah, AI, those are things that will be very interesting in the near future. So also our software development roadmap has to take those developments into consideration. Yeah.
Okay, thank you. We've had a question from Swathi, who says, once we perform the repairs, is it possible to update the data to revise the P-safe values?
Yes, and that's also very interesting because what we aim to do is also for the field inspections and for people that are working on repairs to have mobile software so that it will be very easy through the mobile app to update the pipeline information. So that means also faster and more transparent and traceable data.
Okay, thanks. A question from Dimitri is, how do you input inspection data from different ILI providers?
That's a good question. That, to be honest, I cannot answer at this moment, but I will be pleased to answer it after the conference.
Okay, thank you. Marcelino says, congratulations on your presentation.
All the way from Brazil, wow.
All the way from Brazil. The great difficulty in using these tools is to insert or feed the data into the system. How do you facilitate this activity?
Yes, so that's also where our own experts come in. So because we offer also field surveys, yeah, our experts have the knowledge to handle various data sets. They have experience in what's out there. And then we will also, as at first, try to handle it through mobile apps. And if that's not possible, through importing and exporting in various formats. But if these are known solutions that are out there, I am sure that we have a way to capture that data in the software.
Thank you. We've had a few questions for you from Belgium. I'm going to pick a couple of them. One is PRIMS, does it interface with GIS? And also, does it use standard databases like PODS?
Right now it is based on MapInfo, but in the future we want to also develop it in the direction that it works independently from MapInfo and can interface with various other platforms.
Perfect. Well, Cindy, thank you so much for the presentation. Great to hear about the work that the Sniffers are doing.
You're welcome.